Thank you, Matt, for the introduction. Thank you, Nadia, all the team, and the office for this invitation. I'm from the chemical engineering department from the Technion. I'm also part of the prestigious Grand Technion Energy Program. And I will talk about my work on affordable fuel cell technology for cars. Okay, thank you. In fuel cells, as we know, we have tremendous progress in the past decade, reducing the cost, and we have now the first fuel cell being sold at Toyota Mirai, others on the way. So this is a successful story. However, still the cost is the main problem, and as you can see here, the projection of the fuel cell system cost when we produce in mass production in the past 5-6 years, we have some kind of threshold that we cannot keep reducing that cost, and we are still far from the targets that we need for the automotive industry. The main reason, one of the reasons, is that we keeping reducing the loading. I mean, the amount of platinum that we need per car is extremely difficult. As Professor, as was pointed out by Professor Emmanuel Pellet, the catalyst is significantly together with the membrane. So if we cannot reduce the platinum, so we find it very difficult to keep reducing the costs. So what we work at the Technion is what the work that we have been started at a company called Celera at that time, working on an ion exchange membrane fuel cell. This, in principle, is the same structure of the fuel cell that we know today, but instead of the very acidic membrane that we use in Nafion in the mainstream technology, we're using an alkaline, solid polymer electrolyte. In that way, we can do two different things that are very related to the cost. One is the catalyst, a second the membrane. In the catalyst, instead of platinum, we can now use iron, nickel, and carbon that are 3 or 4 orders of magnitude cheaper than platinum. Also in the membranes, which are very important, instead of the very expensive fluorinated materials, we can use hydrocarbon raw materials like, for instance, polyethylene, that we all know are from our daily life is very, very cheap and affordable. In this way, the membranes and the catalysts that, as you can see, are today like at 70% of the cost, we can reduce significantly to all the system to almost 50%. And in that way, we can make this technology affordable for mass production. So at the Technion, we're working on membranes and fuel cells as well, a membrane and catalyst as well. In membranes, for instance, the main remaining concern is the stability of these membranes. And a lot of publication, we have a workshop this April, for instance, in Phoenix, supported by, funded by the DOE in the United States. And they claim, national labs claim that they have several chemistries, several polymers that are very stable. My colleagues in Germany also presented a very nice improvement, different chemistry, 25 times more stable. But at the Technion, we were working the past year to measure this stability in ex situ, not inside the fuel cells, as we do. And we proved in the past month that those techniques that we were using to measure the stability, those techniques are completely wrong. And we just proved and published this work the last week, and we developed a new protocol to test the stability of the membrane in the fuel cell that actually we succeeded to simulate exactly what happened inside an ion exchange membrane fuel cell. And when we do that and we take our regular polymers that people were happy because of the high stability using old or current techniques, we prove that when we increase the current, we simulate that we increase the current in the fuel cell, that this is what we want to do, actually the polymers were completely destroyed in hundreds of hours. So that sounds like very bad news for the community. Actually, this is excellent news, because using now this protocol that we can simulate what is really going on inside the fuel cell, we can now design the right polymer and evaluate the polymers and choose just the best polymers for this technology. And just a very initial work that we are being done in these weeks at the Technion, we have, with some very special modifications, small modification on existing polymers, we have proved using this new protocol that some chemistry with this modification can be, we can increase the stability by 3 orders of magnitudes. So if we are right and we indeed can duplicate these results, that means that we have already polymers ready for the requirement of the DOE, that this is 8,000 hours for fuel cell for automotive application. So this is actually great news. Also, we're working on electrocatalysts. This is part of the work done at Celera with collaboration. We have published a few months ago with collaboration with Dr. Miles Page, which is here from PO Cell. And we show here, as compared with power that you can get in this technology using commercial available catalysts, we develop a Syria palladium catalyst, bifunctional catalyst, that we increase the power that we can supply almost 1 order of magnitude. That work was published a few months ago, and today, actually, this is still the worldwide record in performance of an anion exchange membrane fuel cell. And this is very close, so it actually meets the DOE target that was set in April in Phoenix for this technology, but that was targeted for the end of 2017. So we are ahead of that schedule, and that's a very nice result. We are at the Technion working on improving this, and this is, seems to be very initial work to be able to get much more power than we need. Also, we're working on several modeling with different partners worldwide, working on different critical aspects of this technology, both ionomers and catalysts. And just to summary up, the Technion, besides catalyst and membrane that I quickly mentioned, we're working on characterization, evaluation, modeling, all the way to the electrodes and making the cells of these anion exchange membrane fuel cells. And together with actually active joint projects of collaborators from 20 different countries, we actually are making happen and making great progress in this technology to hopefully very soon, would like to call it the second generation of fuel cells for automotive. So let me thank part of the group is here, not all the group, but this is actually today the largest research group fully devoted to this technology worldwide. And the sources for the funding also from the Grand Technion Energy Program, but also from the Ministry of Science and here in Israel and the Prime Minister Office, and also several funding agencies from Europe. And thank you for the attention.